numerical Python, right? As per the name suggests, we are going to work with a numerical Python. We will see what all advantage it has over the list. And we will also understand if we already have one data type called as list, then why are we choosing a whole new package called as Numpy to perform any sort of numerical application on the data set. Okay. Let me create one notebook for you. Okay. So I will upload the notes of Numpy as well as one PPT. If you guys want, you can go through both of them, okay, for your learning purpose. So as I told you that Numpy is nothing but one package. Most of the people call this as library as well. So you can consider either package or library, completely depending upon your choice. Okay? Because somewhere if you search Numpy, it will show that it is a library. If you search if Numpy is a package or library, then it will show that Numpy is a package. So whatever your preference is, I am suggesting you to call this as library. Okay? As you consider this as a library only. Even though it is defined as package, but in layman terms, we call this as library. Okay? Now, this is completely dedicated to perform numerical and computational applications on data set. As you guys know that your data set is going to be numeric in nature, right? Basically, first of all, what happens whenever you are having the machine learning model? The machine learning only understands numbers. Okay. So since you are having the numbers, now what if you want to solve some polynomial equation? What if you want to solve some linear algebra, some derivation, some integration? So NumPy gives you this chance to solve all of these mathematical things all at one go on a data set easily. Okay. So previously what happened when we were dealing with a list, we were dealing with the tuple. Of course, we can perform numerical activities or let's say numerical calculation with the help of this within this list and tuple as well. But it was taking a lot of time at first, right? We have to write for loop and then we have to, even if I want to add to list, I have to declare to list. Then I have to run the for loop. I have to use zip built-in function and then perform iteration over it. Then we can do the sum of this. But if you are having the data set of, let's say, 30 features, okay, now we are jumping into the field of EDA, right? Exploratory data analysis. So you need to understand that we call column here as features, okay, and rows here as observations. So consider you are having 30 features and somewhat, let's say, 10K observations. Okay. And if you want to perform any numerical, let's say, calculation on this particular data set, then what you need to do, are you going to run the for loop on this number of observation? Going to take a lot of time because you guys know for loop perform iteration, it picks up one value at a time, do the calculation, then it jumps to the next value. So there is a possibility that for 10,000 observation, it is going to consume, let's say, 5 to 10 minutes of time. Okay. You must be thinking that your system is hung. It is running in the background. That's what for loop does to your data set. Okay. So we avoid using for loop over observations. But of course, we can use for loop for the columns or features. Because as you can see, it is very finite in number, right? A handful of columns we are having, so we can run for loop over it and get the output. But in the case of observation, when we come into the observation, your observations are never going to be 100, 200, and 80. Okay? Always it is going to exceed the value of 1,000, maybe 10,000. There is a possibility that it could exceed a lakh as well. Okay? Because that's why you guys are going to get appointed to deal with a large data set. Okay? So here in this case, the for loop is not going to work. Okay? So that's why we eliminated the use of listen tuple and they declared one whole new library or package called as Numpy. A Numpy will help you to create multi-dimensional array. Okay, so previously what we were doing, whenever we were creating the list of numbers, listen to me very carefully. Okay, suppose this is your list of numbers like this. Now within this list of number, you can see there are all numbers, but we can also declare different data types as well. It is allowed here. But in the case of Numpy, it is completely dedicated for the numerical type of data. Let's say numeric type of data. Okay. Also, it helps you to create this kind of structure, but we call this structure here, which is getting created with the help of Numpy, as array. Those guys who have a knowledge of any other programming language, they must be knowing what arrays are. Right? So array is nothing but it is one ordered kind of data structure which helps you to store the data of similar type. Right? Is it sounding same as that of a list? But it is ordered in nature and it helps you to save the or let's say store the data type of similar type. The exception is just that list helps you to store different type of data. But here, array helps you to store only single type of data. Now, which type of data I'm going to talk about here, you can see numeric. And since I am saying numeric, what do you guys think? What all are going to get supported inside this? When we are saying numeric data type, integer and float. Okay. When we are talking about numbers, they cover these both data types, which means they are integer and float. So Numpy helps you to create the multi-dimensional, single-dimensional type of arrays, and you can also perform arithmetic calculation or numeric calculation over such arrays. Okay. Now the term is changing here. Previously we were talking about the data types. Now we are going to talk about arrays. Okay. Give me a moment. Okay, so for first we are going to do, first we will write one definition for array, okay? So that it will give you the technical understanding or let's say definition for array or Numpy, okay? Wait a minute. Let me clear all of these things. Okay, now first we will talk about what is Numpy. So usually we say that Numpy is a fundamental package for scientific computing in Python. Let me write it down to you. One or two lines just to understand the Numpy library or package a bit more clearly. I'm simply writing Numpy is the fundamental package for scientific computing in Python. Okay. Now the another thing here is that it helps you to create multi-dimensional array. Okay. Now, what is array? If you want, you can search it on Google. And in layman terms, let me explain what arrays actually are. It is nothing but one order data structure which helps you to store similar type of data within it. Okay. It works as same as that of your list. The indexings are going to be same. Everything is going to be same. Okay. Just the term is getting different here because we are using it inside one package called as Numpy. Okay. Now, let's talk about this dimensional thing. Okay. Now, since we are going to deal with the data set in near future, what do we understand from the dimensions? You guys must have heard this thing 1D, 2D, 3D, and then MD, which is multidimensional. Okay. Now, could you give me some real life example of one dimension? So, what we are talking about 1D, 2D, and multi-dimension. So, in real life, 1D, you can see one line, vector also, or some direction. Okay. How we are judging this as one dimension in nature? You can say that in graphs, right? You must be knowing this thing that there are some axes. Okay. We call this as x-axis. I'm going to call this as y-axis. Now, if you are not familiar, please be familiar with that because we are going to use this very frequently. This axis thing. In near future, you guys are going to create graphs and you need to have knowledge of the graphs which you already have created in your school room. Okay. What are scales? What are the points which you create in graph? What is the name of the graph? What is the name of x-axis, y-axis, everything? What are grids? Okay. Now, this is your x-axis and y-axis. Now, you can see they are increasing in two directions. First direction is your x-axis. Another direction is your y-axis. When we say something is one dimension in nature, which means it is only growing in x-axis, then we call this as 1D in nature. Okay. For example, your line. Okay. Whenever you try to create a line, you can only create a line in one direction. Either you can move in the forward direction or you can move in the backward direction. Okay. Whenever you see one highway, you will always see the signboards, right? It always direct you that if you want to pick, let's say, National Highway 61, you need to go straight. If you want to pick National Highway 16, then you need to take a U-turn. What they are doing, the signboards are giving you the direction of your destination. Okay, that is also increasing in one direction, and that's why we say it is 1D in nature. Now, what about 2D? It is increasing in two axes, which means it is increasing along x-axis as well as it is increasing along y-axis as well. Now, some real life example of two dimension. This is very easy. Something which is increasing in both the direction. Age, correct? What else? What else? Okay. Do you guys understand shapes? Triangle, squares, room, wall, yes. A particular wall, if you're pointing, then yes, of course, it is 2D. So, okay, guys, that is 3D Gopal, okay? Let me talk about one thing that whenever we say it is in two dimension, you have to understand that something like your square, rectangle, circle, getting it? Because one dimension is your page, another dimension, the pencil you are drawing on it. Okay. So that is nothing but 2D in nature. It is increasing in only, it is taking only two axes to get created. Getting it? For example, the wall, the cone. No, cone is 3D. Okay, Kavya. Cone is 3D. There is something yellow inside it, right? So the shapes like your square, rectangle, triangle, these all are 2D in nature. Okay. And the basic example which you guys have given to me, So what is the other thing with vector which we learn in physics? Anyone? Vector is something we write like this, right? Scalar. Okay. Scalar and vector. These two are the things. Correct. Yeah. So that is the point which we were talking about. So something which is increasing in two direction, we call this as two dimension in nature. Okay. Now let's talk about already dealt with the real life scenario. Now how it is related to our number. Okay? Now what we are going to call one dimension in number, what we are going to call two dimension in number. So always understand that any array which is increasing only across the rows, we are going to call it as one dimension in nature. Any array which is increasing across x-axis and y-axis, we are going to call it two dimension, and it is growing across both rows and columns. Getting it? So out of these two, which one is a data frame? Is 1D or 2D? Whenever I'm going to talk about data set, it is going to be two dimension in nature. Okay. What two dimensions? One dimension is your row and another one is your column. Okay. This thing is very important because these are very basic things. Why we are learning this? Because once you deal with the data set, sometimes if the data set is in 2D, you extracted the chunk of data out of it. Okay. Now, most of the people fail to understand that it's one dimension or two dimension in nature. So this is the identification. Suppose you are having the chunk of, or let's say, suppose you are having the data frame here, okay, which contains, let's say, 30 columns or 20K rows. Now you extracted some piece of the data out of this, okay. Now you need to remember that is it 2D or is it 1D in nature? Why? Because we have to deal with that particular data set in that particular method. We have separate methods for 1D and we have separate methods for 2D as well. Since we are going to move forward, you will see the importance of these two things. That's why we are discussing it. Okay. Let's move forward. Now 1D and 2D is already done. Let's talk about 3D. Okay. Let me clear one thing very specifically, that we are not going to deal with 3D type of data. But of course, I will show you what 3D type of data looks like. Okay, but we are not going to deal with it. But I will show you how you can if you want to. Now, when I'm saying 3D in nature, could you give me some example, real life example of 3D objects in your surrounding? Okay. Yes, yes. Everything which you guys are mentioning, everything is 3D. Okay. Now, if you want to get the exact explanation of 3D, it increases in three directions: x-axis, y-axis, and z-axis. Okay. Now, when we are having these three axes, you need to understand that. Is it looking like the corner of your wall, or let's say corner of your room? You're sitting in the room, look at the corner of your room. You will see that there is one height of the room, length of the room, and breadth of the room. So your room itself is one 3D object, right? We say cube, cone, and cuboid. All of these are your three-dimensional objects. Now you will see everything which is available right in front of you is three-dimensional in nature. Let's say your purifier, your water cooler, your sofa set, your table, your laptop, everything contains 3D in it. Even your laptop, you can see that it is kind of a cuboid structure. Right? Now, since you guys understood what is 3D in real life, let's talk about what 3D in Numpy looks like. Whenever we talk about 3D, it is always rows, columns, and some third dimension. We don't know what this third dimension called as. Okay. What kind of data we deal with when we are talking about 3D? Images. Okay. You guys know the particular section of machine learning called as computer vision, right? This computer vision deals with the images. Okay. It identifies your face. Most of the best example is your lens card, right? Lens card provide these days your facial recognition, and it gives you the chance to select your frame according to that. Okay. So that is completely computer vision. Now, when I'm saying 3D and we are talking about one image, how the image turns out to be 3D in nature, right? There must be a question in your head. It looks like a 2D. It has length and breadth. Where is the third dimension when I'm talking about an image? So you need to understand whenever we are considering one image as 3D in nature, it is their color, RGB. What is this RGB? Anyone? Red, green, blue. Okay. These three combination of colors create the pixel of your image. For example, consider this is your image, right? Every color which is getting filled in the pixel is with the combination of RGB. Okay. So we say that there is one frame of R, there is another frame of G, and this another frame of B, aligned parallelly to each other. And the combination of these colors make every color of your picture. That's why we say images are three-dimensional in nature. And according to those pixel, we try to deal with the computer vision section of machine learning. Okay. So yeah, of course, we will see that how we can import images in the Numpy and how 3D array looks like. Okay. But of course, we are not going to do anything with it. Okay. I will just show you. If you import some image here, how the array behind that image looks like. Okay. So first we will start with the creation of one-dimensional array. Later we will jump into two-dimensional, and then we will import one image to see the 3D array behind that image. Okay. Let me clear that. You guys know that Numpy is nothing but one package. So to use Numpy, what we have to do? Simple. We have to import it. We always write import Numpy as NP. Okay. Previously, what we were doing for the regular expression, we were simply writing import regex as RE or import RE directly, right? So here we are importing NumPy as NP, so that whatever function or modules, if I want to use of the NumPy, I'm going to use or write simply NP in front of it, not the whole module name. Okay. Running it. Successfully imported. Now, there is one thing for you. There's a possibility that some of your notebook will show error while running this particular import line. What is the reason behind that? It is in the sleeping mode. Your NumPy module or package is in the sleeping mode right now. You have to pip install it first. Okay. So this is not for only NumPy. It is for upcoming every library we are going to deal with or package. Whenever you are writing the import statement perfectly fine, still it is not getting imported. What is the alternative thing you do? You will first pip install that particular package or library. Once you are done pip installing it, then again try to import it in your Jupyter notebook. Okay, let me show you how pip install look like. Since it is already there in my Jupyter notebook, that's why it is showing all requirement already satisfied. If it is not there in your notebook, then it is going to read some of the lines, 5-6 lines is going to appear, and then you are ready to import the NumPy as NumPy. Okay, so remember this whenever you are going to import any future package or library. Okay. Now, Since it is done, I'm going to simply create one-dimensional array. Let me mark it down. Creation of 1D array. Okay. Now, since we are creating one-dimensional array, it is simply np.array. So do you guys understand that np is nothing but your package and dot array is nothing but your function present in that package. Okay. Inside that np dot array, I'm declaring one. What is the data type, guys? Can you identify the data type? What I'm declaring inside the array? It is a list, right? Now you will ask me the question, can't we declare tuple inside it? Of course you can, but it is going to by default change our answer into the list. It is going to create array out of it. So no specific, let's say, consideration that you can pick only list or you can pick only tuple. You can choose either of them. No issue, because the end product is going to be array only. Okay, I'm running it. You can see it is giving me the answer somewhat like this. Now, guys, always understand that I'm going to store this in some variable, let's say AR_1. And now I'm going to print that variable. You will see there is some difference in the output. Previously, we were printing like this. Now we are using some variable. I'm trying to print. You will see there is some genuine difference in that. Previously, it was showing array with the values. That is just showing you the okay. So always try to understand whatever array you are going to create. Always store this in some variable and try to print that variable. Okay. Now the days are gone where we directly use the variable to print inside the Jupyter. Yes, good observation. Very good observation. Keep that thing in your mind, okay? We'll soon have discussion over it. Why there are no commas present in the array. Okay. As you can see, Gurpal already noticed this thing that we don't have commas present inside this. Do you guys know matrix? I'm asking the question from everyone. 10 of you guys present in the session. Do you guys know what matrix is? Whenever you create matrix, you put comma between the elements. Bus. Understand that what we are creating. Okay. So if you want to, no, let's not go there as of now because I'm saying that it is one-dimensional in nature. Understand that we don't have columns here. Okay. We don't have columns here. We only have rows. Okay. How many rows are there? 4 rows. Simple. Now, guys, understand. This is going to appear like this just because your rows should appear like this. Okay. Just because you're creating array, that's why it is getting flattened. But the meaning of this is this only. Not making sense. Getting the point that they both are same. When we talk about the rows, it is nothing but these rows we are talking about. It is just getting flattened because we are using it here in the poetry. Okay, let's move forward. Now, you want to get the justification that we created 1D array, right? Of course, it is looking like a list. How I'm going to tell you that it is an array? I don't get the proper explanation of this. It is looking like a list. If some newcomer, I'll show that newcomer, this thing, newcomer will identify this as list only, not array. For checking the data type here, we completely have a new method. Previously, how we check the data type? With the help of type built-in function, right? Here, we write AR_1 dot data. Okay, what it is showing? Integer 64. What it is talking about? The elements present inside this array. Why? Because as I told you, what is the definition of array? Ordered with similar type of data present inside. Right? So it is telling me that it is integer 64, not list, not array. Okay? It is telling me that whatever we have declared inside the array is integer 64, and we can say that it is array of integer. Okay. Now, if you write type built-in function and write AR_1, then you will see what it is showing. Okay. Let me tell you, for some of you people, if it is showing in 32, no problem. It is just telling you 32-bit and 64-bit. Okay. You might be declared some small number here. That's why it is showing in 32. You guys remember, we learned that in the first session, that is 2, 4, 8, 16, 32, and let's say 64. Okay. So whenever we exceed this limit, it is M32. Okay. This is M64. Whenever we declare elements with higher in range or number, it shows M64. But the data type sticks to integer only. Okay. So even if it is showing M32, no problem. Okay. That is because of the consumption of bit and array it is talking about. Okay. Yes, do we have any questions? Okay, let's move forward. While passing float, it is showing in 64, and while passing large integer numbers, also it is showing in 32 only. Why so? As I told you, right, it is capturing the bits. Okay, so we don't know in the memory where the things are getting stored. So that's why it is showing 32-bit and 64-bit. Since you are mentioning 20, 10, 20, 30, 40. Okay, so if you declare this in the memory section, which section of memory it is? Because it is not happening same as that of your list, guys. Okay, what I told you, this array is going to get stored as whole in your memory. Okay, and then it is going to decide how many bits of memory it is consuming, 32-bit or 64-bit. On the basis of that, it will show in 32 or in 64. Okay. Let's not go deep into it because it actually does not have any sort of meaning. Because it is showing you the data type as an integer, that's what our main concern is. Whenever you want to check the data type, whenever we need to check the data type of the variable, type built-in function. Whenever you want to check the type of array we declared, we are going to use dtype. Okay. Can we declare other non-primitive data type in array in Numpy? Let me tell you one thing, tuple is supported. Okay, because the end product is going to become your array itself, so no problem. Let me show you. I am copying this one. Basically, what is happening, guys, we are taking the help of some non-primitive data type to create array. Previously, we have taken the help of list. Now, if you want, you can take the help of a list. But your end product is going to be array only. Okay, I'm writing AR underscore 2, printing AR underscore 2. Okay, you can see both are looking same, of course. Okay, now if you must be having question that can we declare set here? Is this possible to declare set here? Let's check. Now, what it is, if you want to check the data type of AR underscore 2, and I'm writing I build a function here. Okay, but understand that this is not your matrix which we are talking about. Okay, let's say, you can see, this is not the way we want our array to be. If I'm going to declare some duplicate set of element, eliminate it. Dictionary, the declaration of dictionary is completely different, okay? And the purpose of dictionary is also different. We will be using that in near future. As of now, we mostly choose list or tag, okay? But if we use set, this is what going to happen. Okay. Of course, it is showing you array because as I told you, the end product is going to be array only. But at what cost? It is, we are, in other terms, we can say loss of data. Yes. Any more combinations which you guys want me to create array of? Okay, let's move forward. Now, if you want to check the dimension of the array, right? As I told you, it is one dimension in nature, which means it is growing across one axis only. So you can simply write the name of the array dot endem. Run it. But it is showing 1. Endem means n dimension. What is the number of dimension? AR underscore 1 has only single dimension. Okay. Okay, since we have covered till now, I can see no questions we are having. Let's move forward and let's talk about creating two-dimensional array. Okay, now there are some of the tricks which you guys need to keep it in mind for declaration of two-dimensional array. Very simple. A two underscore AR np dot array, same method for creation of two-dimensional array. Just there is difference in the declaration. Okay. First bracket for one dimension, second bracket for two dimension. Putting one comma. Look into this very carefully and then declare your values. Okay. Now, if you want to print, you can print it. ARR. Okay. So this is two dimension in nature. How it is looking like, guys? That's what I told you. If you guys remember that this, which we have declared previously, this is nothing but row. One row. Okay. Oh, sorry, 4 rows. 10, 20, 30, 40. Like that. Here, we are declaring 3 rows and 3 columns. And if you guys remember what I told you, it is nothing but matrix kind of a structure. So can we call this as 3 cross 3 matrix, where we are having 3 rows and 3 columns. Okay. Again, if you want to check, if you want to, let's identify this array is 2-dimensional in nature, you can check with the number of brackets. Okay, we are having 2 number of brackets here in the start, which means it is 2-dimensional in nature. Also, we are already having the built-in function ARR. No, guys, don't go there. Stay, wait for a minute. Let me explain that to you. Let me. Okay, it is showing you 2 dimension. So understand that, guys, it is not 1 row and 3 column. Okay. For AR_2, it is not 1 row and 3 column. What I told you, it is 1 dimension in nature. If you want to check the shape of this array, shape tells you like how many rows and how many columns are there. Okay, since you are having this question in your mind, that we are having columns also. So you can simply write AR_1 dot shape. What it is giving you? How many number of rows we are having? 4. Do we have any columns? No. If you want to do the same thing for AR_2, simply write print and then let's not write print. Simply write AR_2 dot shape. It is telling you the shape of the array, right? What shape it is showing right now? That's why I told you we always choose less than tuple. Okay, so we will go there. Just wait for a minute. Whenever you are declaring 1-dimension array, always understand that it is only going to grow across the rows. We don't have any column thing here. When we are talking about 2-dimension thing, then we have rows and column thing. Okay. Now, if you want to check the shape here of 2_ARR, you can see now it is showing 3 rows and 3 columns. Am I making sense, guys? Okay. Let's talk about, of course, let me ask you, are you guys here? Okay. Let me ask you the question, not ask you, let's have a discussion over this. What is the difference between Numpy array and Python list? Okay. Now, if you guys can see that if I'm going to create the array, let me copy this. Let's not copy, let's print the array directly here. It is somewhat looking like this, okay? But if I'm going to declare the list, the list is also going to look like this. There is no difference. Let me declare the list here with the same set of elements, okay? And then I'm printing list_1. Okay, there is just one difference, that elements above does not contain any sort of comma, but here in the list, elements contain comma between them. Okay, so is this the only difference which these Numpy array and list carry, or do we have any major difference between them which helps us to perform the computational activities, right? There must be some reason why they declared one whole new package. Okay, not for this comma purpose, right? For example, we are having this list1 and then we are having this list2. Now let me give you one question. Let's see how many of you guys can solve this. If I want to do the sum of all the elements respective according to their index position, list 1 plus list 2, what my output is going to look like? Somewhat like this. Let's say 10 plus 30 means 40. 40 plus 20 means 60. 50 plus 30, 80. And 60 plus 40, 100. How are you going to write the program for this? Don't give me shortcuts, okay? Write a program because we have to write, okay? There is a reason, that's why I'm asking you. Either you guys will write or I'm going to write it. Pick up this two list 1 and list 2, and try to do the sum of these lists according to their index position. Do that. Okay. Array as of now, but if you declare the array and list together, how can you judge that what is the direction of this array and what is the direction of this list? You can declare the same type of list as well. Lists are also multi-dimensional in nature, which means nested list. Property of these two are same. Okay. Okay, let me copy this program out. Good one. Okay. I'm copying this. Receive the program to you guys. Those who are writing, you can take reference from here. Let's see from this. Yeah. Let's start out empty list this declaration, right? Okay. Now, if I'm going to run this list, it is going to show me the output somewhat like this. Now you can see we are having one array 10, 20, 30, 40, which is one dimension in nature. I'm going to create another array with one dimension. You can see my lists are also one dimension as of now. Okay. So I'm declaring one np dot array, which is nothing but one dimension in nature. Let's say with same set of elements 30, 40, 50, 60. Printing this array underscore 3. Now, the major thing here is that, guys, we need to understand the fact that in the definition, when you guys, you must be focusing on this part that Numpy is the fundamental package for scientific computing, which means it is there to make our job easier related to the mathematical calculation, right? And what I told you, if I want to run the for loop over the data set, there must be so many observations in the data set, right? We cannot rely on those observations with the help of for loop. If I'm going to run for loop on those observations, what will happen? It is going to consume a lot of time, take a lot of manual effort, and you must be thinking that the system is hang, but it is going to work in the backend. So to avoid this much activity or manual effort, Numpy gives you the chance to do the computational activities simply. Previously, you have written the program with the help of list in 6 lines. Even if you optimize it, still it is going to take, let's say, one whole line with the help of list comprehension. But the include, let's say, for loop is going to be included in that list comprehension as well. Here, the elimination of for loop is happening. I'm just simply writing AR underscore 1 plus AR underscore 3. That is giving me my final array. Simple. Likewise, you can do the multiplication, division, subtraction. But if I'm going to perform the same thing with list 1 and list 2, what is going to happen? I'm going to simply write list 1 plus list 2. Concatenation is going to happen. Is it a computational activity? Is it helping me to solve some mathematical equation? No. Okay. So whenever you want this kind of flexibility, you can go with the help of list. But whenever you want some computational activity to get done without including for loop or any other conditional statement, you can take the help of Numpy. Declare them inside the array, do this job. It's not only this thing, guys. If something is consuming less space, can we say that? Let's say this program is consuming less space, which means we are going to, let's say, consume less time to run that as well. Running of 1 line of Python statement and running of 10 line of Python statement. Which one is faster? Running 1 line. Okay. Included for loop. It is going to perform iteration again and again. We don't have for loop here. Faster. So the space complexity is good here, which means the consumption of space is very less. The time complexity is also good here, which means the consumption of time is also very less. Okay, and it is very convenient to create and solve. Okay, and that is what the major difference is. I will write that No. We do have a concept of array broadcasting. Okay. In Numpy, this is called as array broadcasting. You can do the multiplication of any shape or size of array with any shape of size of array as well. Okay. Matrix multiplication is also possible. Normal product is also possible. Okay. We will see that with time. Okay, so let's write the major difference between them. Let me change this to Rod notebook. Here, I'm going to say that the content of, let's say, list consist element that contains different data type. That is the major difference between the list and array, right? I told you the definition of array itself says that it is ordered and contain only similar type of data. So, list consists any type of data as its element, whereas array elements belongs to the same data type. That is the first major difference. Second difference is that it is faster. Numpy array are faster compared to that of list. Okay. Okay. Now there is one more advantage which we carry with Numpy array, that list in Python is equivalent to array. No problem. But reshaping and resizing is not allowed. When I'm saying reshaping and resizing, which means what? Suppose you declared array, suppose you declared a list, Python list, 5 elements. Of course, you can shrink and extend the size of that list. It is possible, but reshaping is not possible. Suppose you want to completely reshape the element. Previously, because it is not a matrix kind of a structure. So row and column thing does not exist. So once we talk about reshaping and resizing in matrix, or let's say in array, then you will understand that we cannot do this with list in Python. Okay, so I'm just suggesting you to wait till we cover this particular topic. Okay, and then we'll come back to this particular line again for the justification purpose. Also, your NumPy arrays are very scalable and fast for the computational activity as compared to that of your list. The elimination of for loops, right? That is the major task. Getting it? Any questions? List is 1D? No. List is also multidimensional. You can create n number of nested lists inside each other, and we call this as multidimensional. Yes, you can write that. Of course, this is very major point that it consumes less space. NumPy consumes less space for writing or storing a program as compared to that of list. Okay, when we are saying space consumption is less, you can also add the time complexity is also less. Okay, so you can now modify this answer according to your choice, completely dependent upon you. Okay, look into this, and if you have any sort of question, ask me. Any questions? Shall we move forward? So the last topic of today is indexing and slicing in NumPy array. Okay, it is very easy topic. Yes. Okay, so it's not like that the array only supports numerical type of value, but similar type of value you can see. If you want to declare array of string, all the values should be string. Array of integer, array of number, all the values should be number. Okay, but since we are dealing with the package called as NumPy, we are sticking to the numbers only. Making sense? That is again good point. So suppose if you declare some array with combination of string. Okay, running it, what is happening? By default, it is changing the rest of the elements as string only. Okay, so now it will become array of string. Now, can I deal with NumPy array? No, this is not numerical array. This is now string type of array. If you want to check the data type of this AR_3, array, of course. But if you check the D type, you can see what it is showing. And this is called as Unicode error. Okay, we will learn about this in pandas. What is this Unicode error? Whenever Python fails to understand something, since you are using NumPy, which says you are only capable of creating numerical arrays. But since you are creating string type of array, it is unable to define the data type which you have declared and which is going to give you U21, which means unable to decode type of error. And we also say that Unicode error. Okay. That's why we don't declare string inside the array. Is there any order of priority in the data types? Guys, please do remember that we create array only with numbers. We don't have priority. Okay. We create array with numbers. We mostly choose for the creation of array either list or tuple. Set is not supported. And in number section, you must be having integer and float type values. And we are going to talk about string when we jump into the pandas library. Okay, so we have this particular section there. So don't worry. We'll talk about the string type of data. Whenever you want to declare array, just be sure that you are declaring number inside it. And these two are the specified non-primitive data type for the creation of. Okay. Okay, now let's talk about indexing and slicing. We have 25 minutes. Let's talk about that indexing and slicing. Now, guys, please do revise, or let's say, please make your mind remember this particular topic when we were learning the list and we were also learning the tuple. There was a separate session for the discussion of indexing and slicing, and that's what we are going to do here with the Numpy arrays as well. Okay, I'm picking up the array which we have already declared, which is two-dimensional in nature. 1D is very easy. Suppose you are having array of one dimension, which is AR_1, like this. And these are your rows. Do you understand that? These are your 4 rows. So indexing is nothing but like this. You can simply write AR_1 of 3. Simple, because it is one dimension. AR_1 of 2. Simple, because it is one dimension. Now you will be asking me a question that it also supports backward indexing. Yes, of course it does. AR_1 minus 1. You can see. So the concept of indexing and slicing remains same. Getting it? We are just changing the object here. Previously, the object was list and tuple. Now here we are going to deal with arrays. Okay. Now previously what happened, we were dealing with list and tuples and we were having multi-indexing in there. Here we are also going to perform multiple indexing since it is coming with rows and columns. It was one dimension in nature. That's why we were writing simple one index. Now there was one matrix which we have created previously, this one. Okay. Can we write nested in list? Yes. You can write. You can create nested list. We have done that as well, right? You can create one list and you can declare one list inside the list has an element. It is possible. Okay. That's why your array and list looks similar with no difference. Now, to_array, you can see, let me print it out so that it will look like a proper matrix. Okay. It's looking like a proper matrix. Let me create this whole matrix right in front of you guys. Okay. Meanwhile, you guys, please recall the concept of indexing and slicing. This is 78, 203, 50, 54, 40, 60, 89. This is nothing but one of your matrix, 3x3 matrix. Okay. Now look into the screen how we are performing the indexing here. How the indexing is getting done. Now these are your rows. How many rows do we have? 3. So we are mentioning 0, 1, 2 for the rows. Now we are going to have separate indexing for columns as well. So we are having 0, 1, 2 for columns. Now look into the syntax, how you guys are going to write the answers. While let's suppose if I ask you to pull out the chunk of array from this, how you're going to write the indexing for that, or slicing for that. So understand that, suppose the name of your array is toArray. You need to mention that. That is very necessary. First of all, mention the name of your array. If it is only normal indexing, mention index of row, put colon, mention index of column. Like this. Okay. Here, striding. Oh, my bad. This is not colon, guys. Colon is for slicing. This is going to be comma. Okay. So indexing for rows, comma, indexing for column. Now, since we are going to talk about slicing, first mention the name of that particular matrix. Row slicing separately, comma, column slicing. If you guys forgot how slicing gets done, so we have to mention starting index position, colon, end index position +1, colon, strides or jump. So this same thing for row and the same thing for column, separated with comma. Okay, understood? So we are already, let's say, specialized in this particular indexing and slicing. So I'm directly going to dodge a bullet on you guys for extracting this 10 out of this array. Okay. Now give me the answer for extracting this 10 out of this array. Zero for rows and 0 for columns. Running it. Guys, is this 1D or 2D? If you want to check, let's put this in variable X. And if you want to check the dimension, okay, which means what? What do we understand? What we are concluding from this? That since if you are extracting only single number, it will come out as integer. Okay. If you're going to extract row, that will be 1D. If you're going to extract row and column both, 2D. Okay. So remember that. Always remember, if you are extracting the chunk of numbers out of it, then it is going to become 2D in nature. Okay. So we have to keep our focus in that part as well. Chalo, let me mark another number for you. Let's delete this one. Try to extract this particular row out of this matrix. Now you guys know that it is going to get done with what? Slicing, right? Done. Okay. There are so many possible answers for this. Okay. First, look into my answer. And then I'm going to tell you what is the wrong with my answer. Can I simply write 2 underscore ARR? What is the index position of the row? 0. Putting one comma. Now we can see that we have to perform slicing for the columns, right? And it is selecting all the columns. Can I simply put colon here? You can also write 0 colon 3. No problem. Or you can simply write 0 colon nothing. Or if I want to select everything, can I simply mention colon here? Why to mention any other thing, right? You can simply mention colon here. Running it. What is the extraction, guys? Is it 1D or 2D? It is 1D. Since you are extracting something out of the 2D, it should be 2D. Okay. That's why there is a trick. Always understand that if you are performing indexing, perform indexing in both rows and columns. If you are performing slicing, perform slicing in both rows and columns. If you do combination of indexing and slicing, it will result the answer always in the 1D format. Let me repeat it. Combination should be like go with indexing for both rows and columns. Go for slicing for both rows and columns. It shouldn't be like you are choosing indexing for row and slicing for column, or you are choosing slicing for row and indexing for column. If you do something like this, it will result your answer in one-dimensional format, which is what happening here. Since you are extracting something out of the data set, suppose you are having a table. You are extracting a row from a table. It should be in the tabular format, right? It is not going to come out as list. So that is what I'm talking about. So if I'm going to write, suppose 2 underscore ARR 0 colon 1, which is going to select 0 only and simply putting 1 colon. Now what it is? 1D or 2D? So always understand that this way it is going to work. Okay? When you are extracting something, the dimension should not get changed. Okay? That's what the significance. That's why we were discussing the dimension in the first part. Okay?